Welcome to the Z-Axis training series. I'm Doug Harding, Director of Technical Support. Today I'd like to talk about the chamber test, as we call it. This is designed for products. Normally your product has a hole in it where we can introduce air and we can do a leak test on a seam or a weld or something by injecting pressure through the port and trying to get air to go from the inside out. Well, what happens if your part doesn't have a nice port inside it to pressurize or to pull a vacuum on? What if it's something like this? What if it's a sealed tray? In this case, it's a food tray with a sealed opening. We want to verify the ultrasonic weld on this tray. But there's no nice port for us to be able to inject pressure into and watch to see if it leaks out. So how would we do this? So we have a test we call a chamber test. It uses a technique called metered volume fill. So the reason for this new technique that sounds kind of funny is because a regulator, normally that would provide the pressure, this is a manual regulator. Normally we take high pressure supply, we turn the regulator, and it outputs a very specific pressure. Now these regulators are very good at providing a very precise pressure. I can dial it in and it can stay at that pressure all day long. But what they're not good at is providing the same volume of air in the same amount of time. So if we were to take our test part and put it inside of a chamber and just do a standard pressure decay where we push pressure around the chamber, the regulator might deliver air at a different rate from time to time. Inside this regulator is a spring and a diaphragm, and as temperature of the inside air or temperature of the environment around us changes, those diaphragm and spring change their reaction rate, and so they might, even though they'll go to the same pressure, they might not deliver the same amount of volume. So we need something that's going to repeatedly give us that same volume. So the technique we use is the metered volume fill. We're still going to use a manual regulator, but we're going to fill into a very set volume and then take that set volume of air that's been isolated and take it and introduce that into the test part. So what we need is we need some tooling. So next to our Z5 tester, which has the chamber test inside of it, we have a bit of tooling here. This tooling allows us to place the part. So we have a small nest that the part has been seated into. So inside is a negative space where we have our part, this vial that we're going to be testing with possibly a drug or some special chemical inside of it. We're going to verify that the seal has been correctly set on this vial. So inside the nest, we're going to place it inside the nest, and there's a very close fitting tolerance on the nest. We'd like to have as little volume around the part as we can. What we're going to do then is take this set volume of air and dump it inside this nest. And that nest is going to try and find its way in through the manufacturing defect or the seal that's in test. And if we can do this, we'll see that as a pressure change. What we can do is we set up a test on here such that there's an extra timer to a standard pressure decay test. Normally we have fill, settle, and test, the 3 steps. We're going to add one additional step called a pre-fill, where we're going to charge the reference volume at a specific pressure amount, and then in the fill step we take that isolated pressure and dump it into the chamber. The other thing that aids us in the tester is the tester has a built-in clamp valve that's going to activate the fixture for us. So in this case, it's going to act like a drawer. When I load the part, it slides in under the sealing head, and when we activate the test, what you'll notice is it's going to be lifted up and sealed along the O-ring that was on the test nest. And so that isolates it and makes it a complete test chamber. So when I run a part, we pre-fill it, it does the normal fill step, and then we watch for a decay, and we get a pass status. I can replace a part with one that I know that has the manufacturing defect, that the seal was good. We run the same test again. Again, we pre-fill it. It doesn't make it to pressure because all of that pressure changed. So the math that we're working on is part of Boyle's law. Boyle's law is P1 V1 equals P2 V2. So we're taking P1 as the pressure that's going into the reference volume, which is also V1. When we introduce that across, we should get something that comes into equilibrium. When it meets this new volume, the pressure comes to a test pressure. So we're actually loading a higher pressure into the reference volume such that when these two volumes meet each other, they come to equilibrium. And they're going to come to equilibrium at test pressure. Well, if the part under test has a hole in it, there's extra volume. And when that extra volume goes through the equation, we find that when they come to equilibrium, they come to equilibrium at a lower test pressure. Again, we can set limits around it because each of the test steps has its own set of limits. The fill step has plus and minus tolerance on limits. The settle step has a minus tolerance that it has to maintain the pressure. And then the same for the test step. We have a decay value that's looking for a very fine leak. So in essence, you're getting 3 leak tests in one. You're getting a gross failure or a large failure, then a gross leak, and then a fine leak in the 3 steps of the test simply by running it. Now, there are other examples of other parts that can test. This one happens to be a small cell phone that needs to be tested. Again, there's not a nice way to get the pressure into it. It might be some other electrical type enclosure where we're wanting to verify that the electrical components are IP rated or ingress protection. They're watertight. You can see various things. This one happens to have a cable attached with it. So the fixturing, we have standard sizes. We have a small, medium, and large. This one happens to be the small volume. It's a standard product for us. Really, the only thing that changes is the nest. If you had multiple small products, you would just need one fixture and then multiple nests to each of your parts. And then with one of the 100 stored programs, you would simply name that product. The operator would load it by changing to the right program, placing the part into the nest, and running production. Again, this is a little more fixture intense. You have to have some tooling to be able to hold your part correctly. We're glad to assist you with that, either making it for you or assisting you in understanding what you need to do to make that tooling. If you have any questions, feel free to give us a call or send us an email. You can contact us at sales@zaxxisinc.com. Thanks for watching.